Hey everyone, welcome to another interesting session in the AI journey. In today's session, we are going to talk about the different kinds of activation functions in neural networks, right? In the previous sessions, we have covered the necessity for a neural network, the kind of layers you have in a neural network, and then we've also discussed about the forward propagation in a neural network, right? Where the activation function comes into picture and each of the hidden layers and in the output layer so that that instructs the neural network to take a decision, right? To fire or not to fire the neuron. So let's take an overview of the different kinds of the popularly used activation functions that we have in neural networks. Let's go to the whiteboard. The first one that we discussed is a sigmoid, right? What's the equation of this? It's basically 1 divided by 1 plus e raised to minus x, right? Whereas x can take any value ranging from minus infinity to plus infinity, but this function is going to be bound by 0 and 1. So if x tends to minus infinity, the value is lower bound by 0. And if x tends to plus infinity, the value is upper bound by 1. So where does this sigmoid function prove useful? Let's say you have two values at the output nodes, right? Let's say this is a very high positive value. Let's say highly positive value. And then this is a very low negative value, right? Something like that, right? So if you transform the sigmoid function, then this would give you something closer to 1, right? So this will be a yes, and then this will give you something closer to 0, and this will be a no, right? Something like that. So suppose we have, say, a single node here with a highly positive value, then this will transform to a yes. And if this is a highly negative value, this will transform to a no, right? So this helps you in like binary decision making. A sigmoid function helps you with binary decision making, right? Now, suppose you have multiple nodes at the output, like say 1, 2, 3. Like suppose you have say a three-class classification problem, right? Let's say you want to classify certain fruit into like say apple or say orange or say banana, okay? So now you won't get a direct output like say whether it's an apple or orange or banana, but you'll get three different outputs. And based on which of these nodes gives you a higher proportion, you're going to basically classify that into that particular class, right? So let's say this gives you like say 70, like say 0.75 as a output value. This gives you like say minus 0.89, and let's say this gives you 728, something like that. Right? So these are all different values, and I'm just taking arbitrary numbers. So the function that you use here, activation function, is basically a softmax function. What does softmax do for you? What softmax does is it gives you a probabilistic output for each of these three. Let's say the way this function works is it's basically e raised to z1 divided by e raised to z1 plus e raised to z2 plus e raised to z3, right? This is your z1, z2, and z3. So it's going to be like e raised to, so the softmax value at this node is going to be e raised to, this is going to be 0.75, and then 0 divided by e raised to 0.75 plus e raised to 0.89 plus e raised to plus e raised to 728, right? It's going to be giving you a probabilistic value of each of these. Similarly, the value at this node is going to be e raised to z2 divided by, again, the same denominator, right? So what you're going to get is three values at these nodes in proportion such that the sum of all those three, so let's say the output here comes like O1, and this one becomes O2, and this becomes O3, right? The sum of O1, O2, O3 is always going to be equal to 1, right? Because of this formula, the way it is. So like amongst these three, the maximum, let's say O1 comes out to be 0.31, O2 comes out to be zero point 0.6, say 5, but O3 comes out to be like, I'm just making up numbers. Don't try to relate these numbers to this. Okay. O3 comes out to be like, say, 0.04, obviously, right? So here you see that the value for O2 is the maximum amongst these two. So the algorithm, the neural network is going to consider that this class is the final output class. So it's going to say, okay, so the object belongs to orange, the second one, since the second node has got the maximum output. Right? So that's how softmax works for multi-class classification. And then there's another function called as ReLU, right? It's basically rectified linear unit. So how is this function defined? It's like ReLU equals x if x is greater than 0 and equals 0 if it's greater than or equal to 0 and equals 0 if x is less than 0, right? So how is this going to look like on the graph? This is your x-axis, this is your y-axis. So the line y equals x, that looks like this, right? It passes through the origin. If you look at this function, for all values of x greater than 0, that is this part, right? It's going to retain this part. And for all values of x less than 0, it's going to cancel out this part and it's going to normalize it to 0, right? So the ReLU function looks like this bold line. It looks something like this, all right? Clear? So in this way, we have three popularly used, and each of these three have their different applications, right? So ReLU function is basically used because of its unique characteristics, right? Sigmoid is used when you have a, say, a binary decision to make, and then softmax is used where you have multi-class outputs, right, in a neural network. So these are the three popularly used kind of activation functions. There are variations to ReLU as well, called as a rekey ReLU, which we'll cover maybe later. But then this was just to introduce you to different kinds of activation functions, right? So if this makes you happy, then just give me a like and then in the video at the bottom, and then just give me a comment at the bottom. All right. And if you have any questions or any suggestions, please feel free to comment accordingly at the bottom of the video. So I hope you found this useful. Until then, take care. Bye bye, and see you in another episode with another interesting video. Right? Bye bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.